Hello, today I'm going to start analyzing a tool that's pretty much a bible for an information security analyst but a pentester as well, which is Wireshark. Wireshark is probably the most popular network analyzer or protocol analyzer, depending on how you want to use it. It's a free software available for Mac, Windows, and Linux that allows to capture network traffic and filter it based on specific parameters. The way it works is really simple. You only have to load it like this. Now I'm going to load it from scratch just to show you. That's its icon. Don't worry about this. That's because I'm working as a root user, but I'm in a virtual machine. However, in a physical Linux system, you shouldn't be working with the root user. So that's the reason why you have that overlay. You should create an underprivileged user. Okay, here you see a list of all the available network interfaces we have on this machine here. Most exactly, more precisely, here is a dynamic interface using DHCP, and that's a static interface using this IP address, which is on the same subnet as Metasploitable 2 here. You see, it's on the same subnet. Okay, so I showed you before how to perform a basic network capture with Wireshark, but that was only to show you what the TCP flags look like with some specific types of mmap scans. We're going to delve much more into this right now, and before we do anything, we need to make sure that we set up the interface we want to start the capture in promiscuous mode. Now, the easiest way for you to do this is to enable this. Now, promiscuous mode means that all the traffic that goes through the network is redirected to the network interface, regardless if it's intended for it or not, which means without promiscuous mode, if I start capturing on this interface, I will receive all the network traffic intended for that specific interface and not anything else. Promiscuous mode allows me to see anything going through the network on this specific interface. So, with that being cleared, let's start performing an mmap scan on our target, and at the same time, let's start capturing. Alright, so we're going to capture on this interface, and we're going to use our target website for which we have permission to perform scans, scanme.mmap.org, to perform our scans. So I'm going to start capturing. As you see, I'm going to start promiscuous mode on this interface. In the background, the network interface is connecting to the router. Alright, so we start our scan, and we should be able to see the traffic coming through this network interface here. At the same time, I'm going to load this website, and I'm going to go to a secure website like this. Okay, now we're talking. Alright, so we have different protocols in this network capture, different types of packets, different types of source and destination ports, a total mess. So the question is, how can we sort through this traffic and filter out what we need from this? And here's the power of Wireshark, and that's why it's so popular and it's so commonly used, because it allows you to see just what you want to see. Now I'm going to stop the capture. In the meantime, we don't need to have this capture going on for too long. It doesn't do anything. Now we can analyze the traffic based on the type of protocols we have. For example, we might want to see only HTTP traffic. That's the online certificate status protocol that allows to understand if a certificate for a website is valid or is included in a revocation list. Now, we saw before that we have some HTTPS traffic and we have some mmap traffic. Let's say we want to see only the traffic outbound intended for HTTPS protocol, so on the port 443 TCP. You see, we can use this filter TCP, which is the protocol. This that stands for destination port, a double equal, and the port number. And we see we have some session here. We see the authentication through TLS version 1.2, which is the most current version at this time. You see the handshake, so this is how the client authenticated to the server and established an encrypted session. You see all the traffic here is pretty much encrypted. An interesting thing we can do with Wireshark is to follow the conversation between the client and the server. Using follow TCP string. That shows us the whole conversation, whereas the client request is in colored this way and the server response is colored in purple here. You see that we have a certificate authority because we established a session with PayPal. all the stuff, of course, is a bunch of gibberish because the session is encrypted. So that's very good because nobody intercepting the packets could make out anything out of that. And that's the whole reason why you want to use TLS. Most people talk about SSL, but it's really TLS, by the way. Alright. So you see that there's a way for you to understand much deeper how things are. So now, like we saw before, we can have a look at our TCP packets. We see the whole three-way handshake that took place between the Kali client and our metasploitable virtual machine. We see the number of bytes captured, the source port. Of course, we used a destination, we used a dynamic port, and the traffic was intended for HTTPS port outbound. That's for PayPal. Alright, so this is related to our mmap scan. And you see that the three-way handshake wasn't completed because we have a reset flag here. So if you were a security analyst and you see a bunch of packets like this with the reset flag on, that might probably be an indicator of something wrong going on, because either there's some problem on the server in the network configuration, or it's a sort of per-scanning attack, because if a bunch of packets are reset before completing the three-way handshake, that could be indicator of somebody trying to probe your system and understand what services are running and what ports are open on the machine. So you might want to fine-tune your firewall rules and drop this traffic altogether. Under a forensic standpoint, you might want to make sure your capture wasn't compromised. So now we're going to save our capture here. So under a forensic standpoint, you want to make sure this network packets weren't tampered with. So you might want to hash this file here. You can use different hashing algorithms to digitally sign a file with Linux, Windows, or OS X. I personally like to use command line. I don't like third-party tools. And in Linux you can have two types of commands, practically. MD5 sum to calculate an MD5 hash, and SHA sum to calculate a SHA hash. Now you can have several types of SHA algorithms. What I'm going to use is this one. So what I'm gonna do is launch the command and plug this in as an argument of the command. And here is my hash value. So you might want to store this hash value into a file, maybe a text file like this, for example. And after your analysis ends, you're gonna hash the same file once again, and if you did things correctly, the two hashes have to match. So let's say you finished up your analysis and you repeat this operation once again. So you're going to create another file called final hash. At this point, we can analyze the differences between you see there's no difference. They match perfectly. So we can be sure our analysis is foolproof and it stands in court. This is very important, but that's something you want to make sure you do, even if you're not with law enforcement or you're not a forensic examiner, because that proves that you perform your research correctly. So that can be useful even with regards to your boss. If you have to, defend the position with regard to your customers or something like that. So that's something you should keep in mind. And I should probably have started talking about this in the first place, but I'm a hacker, I'm an anarchist, and I don't follow a linear order. I apologize for that. Wireshark is very useful to analyze traffic patterns and especially to detect anomalies in the network. Alright, so this is just an introduction. Next time we'll see how we could use Wireshark in a malicious way to understand what's going on within our network and read through the information going through. And we're gonna have a look at other fun stuff we can do with Wireshark, especially how to filter the traffic using something like BFF language, which we'll see next time. So until next time, have a good one, guys.